This is Joule, Calorie, and Specific Heat by Emily Fan. So let's start with the Joule. The Joule is the basic unit of energy in the International System of Units. It was named after James Joule because he showed that this unit, which was originally meant to measure work, could be converted into measurements for heat, and it takes about 1 joule to lift a medium potato by 1 meter. Now let's move on to the calorie. The calorie is another unit of energy. It is the temperature needed to raise 1 gram of water by 1 degree Celsius at standard temperature and pressure. It is different from the calories with the capital C that we use to measure food, where 1 kilocalorie is equal to 1,000 calories. At times, you may need to convert between units. 1 kilojoule is equal to 1,000 joules. 1 kilocalorie, or calorie with a capital C, is equal to 1,000 calories. 1 calorie is equal to 4.184 joules, and 1 kilocalorie is equal to 4.104 kilojoules. An example conversion problem is converting 500 calories into joules. So first you start off with your base equation of 1 calorie equaling 4.184 joules. And then, because you have 500 calories, you multiply the left side by 500. You also need to do that to the right side as well with the joules. After doing so, your new equation is 500 calories equals 4.184 times 500 joules. And your final answer will be 500 calories is equal to 2,092 joules. Now let's talk about specific heat. Specific heat is the amount of heat per unit mass you need to raise the temperature of something by 1 degree Celsius. Substances with a higher specific heat require more energy to change its temperature and vice versa. The specific heat of water is 4.184 joules per gram degree Celsius. To calculate specific heat, use the equation Q equals Cm delta T, where Q represents the heat added, C is specific heat, M is the mass, and delta T is the change in temperature, which is the final temperature minus the initial temperature. So we can use a real-life example to calculate specific heat. Let's try and find the specific heat of apple juice. One day, Caitlin decides that she wants to calculate the specific heat of apple juice. She pours out a cup of apple juice and puts that into the microwave, making sure to take the temperature both before and after. She then records her data where volume is 240 milliliters and she added 9,288 joules of heat to the juice. Her initial temperature was 22 degrees Celsius and her final temperature after it came out of the microwave was 32 degrees Celsius. She starts out by finding her delta T, which she got to be 10 degrees Celsius. She then uses the equation that she learned in her chem class, and she fills in all of her information that she found in her experiment. She then gets that 9,288 joules is equal to 2,400 times the specific heat. To find the specific heat, she then divides both sides by 2,400. After doing that, she found that the specific heat of apple juice was equal to 3.87 joules per gram degrees Celsius. To go over everything that we learned today, we learned that both joules and calories are units used to measure energy. 1 kilojoule is equal to 1,000 joules. 1 kilocalorie is equal to 1,000 calories, and 1 calorie is equal to 4.184 joules. And finally, specific heat is how much energy it takes to raise a unit mass of something by 1 degree Celsius, and it is measured in joules per gram degrees Celsius. Thanks for watching.
Created using Powtoon.